Okay, so you were asked how to use sine and get to cosine series. So this guy can be written as the sum -1 to power n x to power 2n plus 1 divided by 2n plus 1 factorial and starts from 0, goes to infinity, right? So what's the relation between sine and cosine? What is the relation between sine of x and cosine of x? You all know that if I take the derivative of sine, it becomes cosine. Well, this is what we learned in elementary calculus. So what are we going to do? We're going to take the derivative of each term. This is basically a polynomial that can be written in shorter, nicer form in series format. So let us take the derivative of each term. So on the left-hand side, sine becomes cosine. This is obvious. The derivative of x is 1 minus the derivative of x to the third is 3x squared divided by 3 factorial. 3 factorial is going to stay the same, which is the number. Plus the derivative of x to the fifth is 5x to the fourth divided by what? 5 factorial minus the derivative of x to the seventh, 7x to the sixth divided by 7 factorial plus the rest of the terms. So let us simplify. Now simplify to recognize the pattern. Ooh, that is interesting. So cosine on the left-hand side is equal to 1 minus, here you have 3x squared divided by 3 factorial is 3 times 2 factorial plus 5x to the fourth is divided by 5 factorial, which is 5 times 4 factorial. So remember that n factorial can be written as n times n minus 1 factorial. Why you have 3 factorial equals to 3 times 3 minus 1 factorial, which is 3 times 2 factorial. 5 factorial can be written as 5 times 5 minus 1 factorial, which is 5 times 4 factorial, and so on. And this guy is minus 7x to the sixth divided by 7 times 6 factorial plus the rest of the terms. So this is basically algebra. Cancel out 3 and 3, cancel out 5 and 5, cancel out 7 and 7. Well, cosine x can be written as 1 minus x squared divided by 2 factorial plus x to the fourth divided by 4 factorial minus x to the sixth divided by 6 factorial, which is basically can be written as the summation. So here you have the very first term is going to be positive, right? So here you have -1 to power n, and it doesn't have any x in it. So going back to the exponent here, this exponent must be 2n divided by 2n factorial. So down here, and it starts from 0, goes to, well, infinity. If I plug in 0 into n, I get -1 to power 0, which is 1, x to the power 0, 1, and 0 factorial, as you remember, is 1 by convention. Okay, so if I plug in 1 here, I get -1 x to the power 2 divided by 2 factorial, which is the second